Last time we have seen the Sobel edge detection. So in today I'm going to walk you through one of the most important algorithm in computer vision developed by John Canny in 68. So this algorithm is constant is the let's see the gold standard for edge detection, and it's used everywhere from the medical imaging to autonomous driving. And last time we have also discussed what is the edge detection. And in today's video, I'm just focusing on Canny detection. So the Canny edge detection algorithm consists of five main steps. So in the before detecting the edges, we have to I mean the algorithm itself, it's blurring Gauss blurring for applying the Gaussian blurring for noise reduction. So as you see last time, we have sometimes for the Sobel edge detection, sometimes we have edges that are not edges. So for this we need to reduce or remove the noise before detecting the edges. And the second one is gradient calculation using Sobel operator. It's this Canny algorithm. It's only updating optimization with the Sobel algorithm. So the third step is applying non-maximum suppression for thin edges. And the fourth one is double thresholding to classify edges. Is it okay or not? Is there for instance, these edges are have to be let's see appeared, or let's see remove them from the edges. And the last one is edge tracking by hypothesis to connect the edges. Sometimes we have let's see, weak edges, but they are, let's see, connected to the strong edges. So this we have to keep these edges, weak edges. But let's just start with this. Let's assume that we have this original image, 8 by 8 grayscale image. Each pixel has an intensity value from 0, which is black, to 255, which is white. And keep in mind, for the edge detection, we have to have a grayscale image. I mean, color images is not applied, so we have to convert the color images into grayscale images. So because we are not let's see interesting in colors, we are only interesting in the intensity itself. And for the our demonstration, I will use this image for the 8 by 8. And if you see this left hand side, left part here, and this one here, if you see there's an edge in this area here. Why? Because there's somehow gap. Well, let's see, it change big change between this intensity 60 to 200 and etc. And of course there's a edge, for example, from this pixel to this, because why? There's the intensity is changed. We will see how to do this. And let's see, this is our matrix. And for the first system, we have seen we have seen it has four mainly five steps. Gaussian blurring. So applying the Gaussian blurring to reduce the noise, and this is the Gaussian blurring. So how is this working? You have to get, let's see, a filter. Let's see, 1 1 2 2 2 4, and 1 2 4. I mean, this divided by 16 has to be here, indeed. So let's see, we have this 3 by 3 filter, kernel filter, and we have to, let's see, for instance, we need to apply for this pixel here, and this pixel should be in the, let's see, like this. No, I am not able to do it. So let's see, this is the mid pixel, and I have to take one pixel from here and one from here. So because there's no pixel here, I will add 0. I will add padding zeros around the images just to keep the image as it is. And this we have discussed in the neural network and CNN, of course. Now I will apply this. I will try to, let's see, I have here 0 and here 0, 0, 0, 0, 0. Because this pixel here 50 has to be let's see, in the mid of the uh, mid of 3 by 3. Say for instance, if you have 3 by 3, for example, this here and this here and also this here. So I have here from here, I have 3 by 3, and the mid pixel is 212. Now for this filter, assume that we have this filter here. I will apply multiply 1 times 250, then plus 2 times 210 plus 1 times 214, and etc. for the whole stuff. Please just keep in mind, just you can go back to the Sobel algorithm. It's already explained. Now this is the result, and they have to divide it divided by 16. Why divided by 16? Because the sum all of these filters, let's see, the n of the kernel are 16. So I will have to divide it by 16. This now I will get, let's see, 100, 118. And 118, it will be, let's see, replaced by the mid of this one here. Just for example, so in this example, we have seen, we have taken this, the 200, I know is 200, 55, 200. I mean, I have taken one example, but now I forgot which one. 50, not 50, because there's no, there's also 200. Anyway, so, oh yeah, so, this is a 200 here. So you can see 50. And then I just forgot with the mid of this filter. This is the original image, and they have 200. Maybe this one here, but this center will be 70. But let's see. Just I did the mistake here. Now after replacing each value or each pixel with after, let's see, Gaussian blurring. Now I will have this, for instance, this is the original image after the calculating the Gaussian blurring. Now I will try to apply the Sobel principle, which is calculating the horizontal and vertical edges, which with the same, let's see, filters. And the gradient will be like this. Please have a look in the Sobel algorithm. Now we have to identify the magnitude and direction. Magnitude, it's because we have the direction, the edges in x and y directions. Now we have to combine this to get the edges, the final edges. The last one, not the last one, the next one here is non-maximum suppression, which is also used now. I mean, this one used in most of the algorithm, like for instance, YOLO. If your system is detecting multiple objects, and you have to calculate the overlapping between these bounding boxes and select the maximum one. So here we need, the system is think edges. Sometimes you have, let's see, bold edges. Let's see, big edges. Now we sometimes we need to just to thin these edges to just detect their final edges, and which is thin edges the idea. So now here, after gradient, edges are often thick bands of high magnitude pixels. Now we need to thin them to single pixel line to precise edge detection. So this is before suppression, and this is after suppression. But how this is working? So I have applied here. I have for each pixel determined its gradient direction. So the second one, round the direction to one of the four angles. So 0 is horizontal, for instance, horizontal and vertical. So, horizontal, compare with left and right neighbors, and diagonal, compare with top right and top left. So let's see here. I have this pixel here. I have gradient magnitude 150. For instance, this is the after applying gradient. No, this is after applying the edges and magnitude. Let's say assume this 150 is 1 pixel. For instance, not sure if there's an one here, 150, 150. It's fine. Of course, there's 150. Now we have to calculate the gradient direction, which is now it's zero horizontal edges. So we need to you see the left neighbor magnitude is 120, and the right one is 140. Let me just see where's the 150. 150, 100. Maybe sometimes so because the calculation sometimes it's difficult to keep the pixel consistency, but it's the same here. Now let's just see. We have the gradient direction is zero. Now we have to see the left and right, and you can see since 150 is greater than these. Now we have to keep this pixel as it is 150. Let's see. Now let's see for the another pixel which is 130. I'm not quite sure if it's still here 130, but let's see for instance this one here 300 431, and we have to get the direction using this here gx divided by gy divided by gx to find the direction. And for this example here, we have seen left is 140 and right 125. Now, if you see 130 is less than 140, so this pixel here will be set to 0. This called the non-maximum suppression. And after the fourth step after detecting let's see the non-maximum suppression, we have to apply double thresholding. So sometimes you have edges, and you have to if you let's say add one threshold. Sometimes you have if you see let's see 50. So the 50 any value is any pixel is greater than 50, it will have let's see appear as edges. Less than 50, it will not be appear. It will convert to zero. Let's see, set reset to zero. But the Canny algorithm, they said I need two different thresholds: maximum threshold and minimum threshold. For that we have let's see three let's see maybe 20. The minimum one is 20 and the maximum is 70 or something like this. This is we will see in the Python example. And if the value let's say you have 30 and 70, and we have to go here after the suppression here. For example, this here it will be we say 30 and 70. This will be 0 by default. I mean, because it's less than the threshold. This just for example. And after applying this, we will see strong edges, and this is the weak edges here. Now for the tracking, sometimes you have a value. Let's say, for instance, I just forgot to add this one step here. Let's see, like this here. For instance, this is the edges here, and you can see this is the high. For example, these pixels are more than the greater than the threshold, and for example, this C here, it's half of this is weak. I mean, from this point to this, I mean, from this point to this point, they have weak. But they said if they are connected to the strong edges, for example, it's connected to the strong edges here, so we have to keep this one here will be ignored, and also this one will be ignored. So now we have only this edges and this here. So this is the Canny algorithm in a let's say free detailed example here. So now I have here the same example I'm using for the Sobel. So I have just copied. So now we can see Canny. because I have just copied the example just to make it consistent. So here I have the image. This is the same image of the Sobel algorithm. Now I have to blurring the image with 3 by 3 with 3 by 3, and the sigma, or let's see the sigmoid, or let's see standard deviation is 1. And in this one here I have to calculate the Sobel. Oops. Sobel and in the x direction and y direction. And let me just show you the result here. So this is after blurring. If you see just the original image like this, now you can see the after the blurring we have somehow removed some details and make it, let's say, some clear somehow. And here this is the, the, the the edges in a x direction, and this is in a y direction, or the horizontal and vertical. And this is the combined. Now we have the threshold of this of the canny, for instance, 30 and 90. So you can see this is the edges. And if you see now, I have thin. Now it's considered here as a two edges here. You see, and instead of one edge, and also this one here. I think that's it for today. And if you have any questions, just drop it down in the comment below. Thanks for watching, and see you next time.